Dear colleagues, it is our pleasure to present paper decision-making automation for UAS operators using operative meteorological information at the first International Workshop on Computer Information Technologies in Industry 4.0. The paper was presented by Yulia Averyanova and prepared by Yulia Averyanova and Evgenia Znakovska at National Aviation University. In this slide, the brief content of the presentation is shown, from the introduction till the final remarks. The automation of many processes during the productive activity and service provision, integration of different technologies and implementation of Internet of Things in different branches of industry, active utilization of cloud technologies, and looking toward the artificial intelligence and machine learning in the operation of industrial facilities identify this current period of industry transformation as Industry 4.0. In turn, the progress in engineering and technologies in various areas of industry has become a driver to use the range of sensors and special software to obtain, process, and analyze the huge volumes of data. On one side, the increased volume of information helped to increase the efficiency of different operations, optimize them, implement predictive maintenance, help when decision-making. On the other side, the information should be properly processed and analyzed. It should be relevant and contextualized as well. This in turn required the development of the methods and algorithms to operate with this data for further use in decision support systems or in the systems of automated control of industrial operations. One of the technologies that can be successfully used to obtain real-time data at different stages of productive activity is unmanned aircraft systems. Some advantages of using UAS for different industrial applications indicated at the left panel of the slide. At the same time, there can be distinguished some restrictions on drone operations. They are connected with the hazards and risks when UAS operations. The risk analysis should consider the nature of modern UAS system as cyber and physical systems. The risks can be divided into natural and man-made and intentional and unintentional. An example of intentional man-made risks can be the cyber risk. The natural, unintentional risks are often connected with meteorological hazards. This is because the operation of the physical and cyber parts of the UAS is dependent on the weather. Information about the meteorological situation and weather phenomena that can impact the UAS flight and operation is highly important for different industrial applications. So it was our motivation to organize the vast, diverse, general and operative information and to enhance the automation of the process. In this paper, we have made the analysis of weather-related risks for UAS focusing on agricultural application. The peculiarities of such analysis is the weather-related restrictions not only for UAS flights but also for different agricultural mission performance restriction and restrictions for the devices and sensors that can be used for mission realization. The summary of the analysis is shown in the table on the slide. After analysis, we define the factors that should be taken into account when decision-making and consider them in the developed algorithm. The list of the factors are shown in this slide. The first four factors are introduced in the algorithm as input data, then the meteorological general information. At this stage, the meteorological data can be collected from the available resources, including specialized and general Internet resources and official meteorological databases. Then the calculation of UAS characteristics for current weather conditions is made. The next step is the comparison of UAS sensors, mission and area weather limitations with present meteorological conditions is made. After comparison and evaluation of the possible weather-related risks on the basis of a risk-oriented approach, the recommendations to perform the flight and fulfill the planned mission are issued. But the atmosphere is a highly dynamic medium, so the key thing of the algorithm is that after the beginning of the flight, the UAS is used as the mobile platform to obtain real-time meteorological data. This data from one side is transferred to the cloud service, from which it can be used by other participants of flight on demand and to form the data set of real-time data for operative use. And from another side, it is used for operative correction of initial meteorological data and to forecast the boundary layer turbulence. So, the algorithm makes the comparison of the operative data with initial meteorological information. If significant deviations or turbulence presence, then go to the re-evaluation of the limitations. In this case, the new recommendations can be given. On the basis of the proposed algorithm and weather-related hazards analysis, we developed the software for the automation of UAS operators' decision-making. In this slide, it is possible to see the interface of the application and 3 simulated decision-making cases. We can see for the first 2 cases, the state of the atmosphere for general flights and planned mission is quite favorable. The third mission, spraying chemicals, can be performed when wind speed is above 4 meters per second and the absence of any convective movements. So, the average wind 5 meters per second is below the required minimum for the given mission. And to conclude the presentation, it should be mentioned that the developed decision-making software allows to provide the individual user-oriented services, obtaining but are not restricted. Information on demand, real-time information, information for interested area, mission-oriented information. The use of UAS as a platform for sensors placement to obtain operative data allows to form the database that can be located in a cloud service for the convenient use of the interested authorized user. The information can be continuously exchanged between humans and between machines and machines as well. Thank you for your attention.